So I'm tempted to lube up these bearings. So could grab my grease gun, stick it right on there and pump away. The only thing is, just because that's a Zerk fitting doesn't mean that this is supposed to be grease put into these things. You know, I think there are some instances where they use Zerk fittings and it's for actually putting oil down in there. And I'm not sure, so I think I'm going to consult the internet. Hopefully there's something on the Baldor site itself that might help me understand what I should be doing to that, and if not, I'm sure I could find something in a forum somewhere from a motor guy. Practical Machinist website is an excellent source for just about anything, even remotely machinist related, because I mean there are other forums on there, and there's a forum on there just about converters and three-phase and all that, and I'm sure I could find a proper forum to post a question about this motor if I have to. Can't say enough good stuff about the Practical Machinist website. It's interesting. When I turn this motor, which way does this motor turn? It turns that way. So it's a clockwise rotation. And I just noticed that when I very little noise that way, but when I turn the motor backwards, you hear that? I don't know if that's going to come on. Let me get the camera close. It's definitely in the back here. I should take the model number and Google this motor. Maybe it's... I'm really curious about why that slows down on the spin down when the power's already disconnected. How the heck is that happening? Is there a centrifugal switch in there that shorts a couple of windings together? Shorts two wires going to a winding together to basically create a induction break? I mean, that's kind of weird. Alright, in case there are any guys who really know motors out there, I might as well share with you what I'm getting for information off this data plate, because it's chock full. Unlike some of the modern data plates I deal with, this has got all kinds of information on it, and I'll be the first to admit there's several things on here I don't understand. Well, the first is, of course, the catalog number. It's an L13191, or an L1319I, because I noticed that the ones have little lines at the bottom of the one, and the last digit doesn't appear to have that line, so I'm thinking that's either an I or a small l, but there's a capital L at the beginning. So by process of elimination, I think we're looking at an L1319I. The spec number 35D as in Delta 01-371. Frame is a 1451. Or 145, that might even be a T. Serial number is 176, 1.5 horsepower, 115/230 volt, 20/10 amp, 1725 RPM, 60 hertz, or cycles as some people say, single phase, class B, SER.F. That is service factor, 1.15. I believe that's pretty good. I think a service factor of 1 is a motor that can run at its rated output for 100% of the time, 24 hours a day or something like that. I forgot. I remember a while ago that was explained to me and I forgot what it is now, but anything above 1 is, I think, pretty good. DES has a letter L. I do not know what that means. Code, letter K. Well, I don't even know what class B means as opposed to other classes. Full load EFF. It must be full load efficiency, 68%. Well, that seems kind of low, but maybe for an electric motor that's okay. P.F. I'm thinking that's power factor. That's just a guess. 74%. The rating, 40 degrees Celsius, AMB, then there's a space F. So I think that's 40 degrees, well, it's 40 degrees C, 40 degrees Celsius. AMB, I'm thinking that might be short for ambient temperature. And then there's a space where they would have put the Fahrenheit equivalent, and that's what the F is for. So if we convert 40 degrees Celsius to Fahrenheit, we get, I don't know off the top of my head what that is, but I guess that's the operating temperature that it's optimal at, and probably when you go above this temperature, you can start throwing some of these efficiency numbers in that out the window maybe. I don't know. There's a lot of stuff you don't know. Oh, just a quick correction. The catalog number is an L1319T. I looked at it under stronger magnification, and I could see the top of the T lines up right with the top of the box here, so it was kind of obscured. Well, it's another Sunday morning sneak down, and it's been a day since I was down here looking at this motor and playing with it. So I did a little research on the internet, and it's pretty straightforward. Put in the model number, it popped right up. This motor is actually still available today through several suppliers. It's depending on who you buy it from, anywhere from like a high 200s to low 300s to replace it. And it's actually from the Baldor Industrial Division, and I guess it's a pretty good motor. And it does in fact use grease for the bearings, and basically the specifications are, I forgot what they specify, it's a particular type of grease, but in reality it's just going to be electric motor grease. And one of the interesting things I learned is apparently just on a general website for putting grease in motors is that generally speaking there is a relief port somewhere, and you're supposed to open the relief port, clear it, make sure there's no hardened grease in there before you pump fresh grease into these motors. Interestingly enough, I don't see one outboard on this, but I'm noticing right in the line here we've got this little area right here, and I'm wondering if that's where it is. If that's the case, then I'd have to take the motor off of the plate here to get any grease in it. Now here on the pulley end of the motor I can get to that area, and I just tipped this up and cleaned this up and scraped over here, and there's nothing there. This is just a place where when they cast this on the motor they apparently left this there. There's another one here, and there's another one here, and none of them have any sort of port or screw to take out. So much for that being a relief port for the grease. So I don't know, I guess by design on this one, maybe the grease is supposed to just, the old grease is supposed to be displaced and squeeze out the back and make a mess. That seems kind of weird. Well, right now I'm more concerned with this little pulley runout issue here. What I'm going to set up a indicator. And on second thought, before I go through the trouble of setting an indicator up on the thing, I think I might just take this apart to see whether or not there's even anything I can do about it. Because I mean, there's not much point in worrying about it if it's not something I can adjust. Okay, so I loosen these 3 bolts. That doesn't seem to be having any effect at all on the mounting. Let's see, I see a couple of holes here. Are they threaded holes? Yeah, looks like it. Alright, so I reinserted 2 of the bolts I just took out into these 2 threaded holes. And I wonder if these are holes for pulling the pulley off. Yeah, that's pulling off. Alright, so here's the anatomy of the beast. What we've got is probably a tapered cone here that this is drawn up onto and tightened as it does that. and then what holds this onto here must be something that's hidden that we didn't see. Well, that's keyed. Alright, hold on. There is no... I'm looking in the sheave of the pulley there for a hole that would hide a screw or something. There's nothing there like that. I guess the way this works is this. Alright, so you can see there's a slot in that centerpiece right there on both sides. So what that is that's got a slot cut in it, and then what happens is when this is drawn up, that's probably tapered. When this is drawn up and tightened, that squeezes down that slot and has a clamping action of clamping this outer piece onto here. So now with this down and off of there, that slot should be able to open up a little bit, and I should be able to pull this piece right off of the motor shaft. That's just some kind of a sleeve. Tell you what, that might be my problem right there. This appears to be some sort of a homemade bushing. Because that saw cut that cut right there, looks like that was done with a hacksaw by hand or on a bandsaw freehand or something. That does not look good. So I think the first thing I want to do is maybe get this sleeve off, clean this shaft off, up, and indicate the shaft. Because if the shaft is bent and that's my problem, well then it's a non-starter. I'm not going to be able to do anything about it, and I'm just going to have to live with that wobble. Alright, so here's my setup. I got my little machinist vise with the Mighty Mag base, and I adjusted this indicator on here, and I've got it on there and zeroed. So of course obviously when it goes by the slots there and the keyway, it's going to do some weird stuff, but I can get an idea. Oops, yeah, it falls into the keyway. That's not good. Alright, hold on. There we go. So hopefully there's not too much glare on this indicator. I'll even zero it just for the hell of it. Whoa. Oh, that's falling into the slot right there. That's why it just went haywire. So let's see. We got a there's my high spot. Well, looks like 16 thousandths. Alright. So, and that's actually here, and it might even be more out of whack at the end here. Let's see. I'm not going to bother zeroing this. I'm just going to do the math in my head. So let's just call that 10. Same thing, goes up 2 thousandths and then drops down even further, about 18 thousandths, and starts coming back up again. So let's pop that sleeve off and see what happens. Without even cleaning up the shaft, I'll check it. Alright, so we're at, well, let's zero this again. See, I can go all the way around, and needle bounces a little bit because there's rust on the shaft here, but basically until it falls into the slot there, that's right on. So here's my problem. This homemade bushing deal is the issue. And obviously we need something in there because this is not the right size for this. Otherwise, why would they have put that in there? So I wonder what's wrong with this bushing. I mean, there's rust in there, but I don't believe that's going to be what's throwing this thing off that far. You would think that the clamping action would keep this straight. So obviously this slot has to line up with this slot so the keyway works. But this looks like this is crooked. Looks like the slot's not even cut straight. Yeah, it's not. Ow. I wonder if the thickness of this material wasn't uniform. I mean, I wonder what this was cut out of. I can see the turning marks that this was, looked like this was made on a lathe, or the OD of this thing was fine-tuned on a lathe. Other than some rust that's going to need to be cleaned out of that bore, I don't see anything horrible going on in the bore. Alright, so this shaft is 0.874, just about 0.875, so that's 7/8, that shaft. 0.994, 0.993, somewhere around there. It's got to be 1 inch, right? So I think I need a bushing to go from 7/8 to 1 inch. And then I think I'd be golden. So before I set this aside and until I can get that bushing, I'm going to do one more thing, which I don't know if you guys are curious at all, but I am. How this runs without that pulley on there. It still vibrates, but it does seem to vibrate less, which makes sense. I was curious about the uniformity of this sleeve, the thickness of it, and it's like 73 thousandths, 65, 54, 61, 66. I mean, even if some of that's just the caliper's not seating exactly correctly, there's still something going on here with the thickness of this not being uniform. 68, 62, 68, 60. So it appears what happened was when he turned this, whoever made this on a lathe turned it, something was out of whack. So what he ended up with was he ended up with a it's not excuse me, the bore is not concentric to the OD of this, so that's probably where his problem lies. So I got two problems. Problem number one is I got to procure a bushing. Problem number two is the bushing is going to have a slot cut in it for this keyway, and since the milling machine is not in operating condition, I'm going to have to just probably, I don't know, cut that freehand or something, which is unfortunate. Well, I did a search online, and it turns out that they actually make these sleeves, especially for the purpose of changing, for putting a larger size bore pulley on the shaft. So, and I did find one that's 7/8 by 1 inch, and it has the slot already cut in it, so that you can have the key stock in there. Oops. The other thing I found was that these types of hubs here, that I can also, as an alternative, I could have just ordered another one of these hubs to actually fit the 7/8 shaft, and that would fit this pulley here. But this obviously is more money than this, so we're going to go with ordering one of these. And I think the one that I saw was only a little over an inch long, so it might have actually been shorter than this. So I think when I order it, I might order two, because the sleeve's only a couple of bucks, and I pay like $6 shipping on it. And the alternative is I can't get this locally unless I go into the city, and I'm probably not gonna be going into the city for a little while anyways. And don't want to make a special trip just for this. Although, wait a minute, no, that's not true. I have an appointment in the city this very Thursday. Of course, there's no guarantee they're going to have it, and even if they do, it's probably going to be a little more expensive than the supplier I found online. Believe it or not, I've seen these on eBay and commanding as much as $20 a sleeve. So, well, anyways, so for the time being, I'm going to clean this shaft up, and the easiest way to do that is to just grab a wire brush and hold it up against this and run the motor. Oh yeah, of course the other way is to just grab a piece of a small piece of sandpaper or emery cloth, and you got to be careful how you do this. You don't want to do this in a way, you never want to wrap. I can't take a long strip and wrap it around your finger. Looks pretty good. Well guys, it's the Saturday. It's the last Saturday morning of August 2015, and back to work on the Vernon for a little bit today, and been trying to clean and organize the shop a little bit. Well, it seems here in my area of Massachusetts it's been a veritable feast of items popping up for sale in large numbers. Not just the occasional piece here and there on Craigslist. You got a lot of pickers out there now. You get even guys advertising that they're buying anything with the name Starrett or Mitutoyo or Loris on it, and then turning around and they're turning around. Some of it's popping right back up on Craigslist, and then a lot of it's probably making its way to internet sales, where it's pulling the highest dollar. Especially something small you can ship, and there are parts of the country where there's a veritable desert as far as good used tooling and things. So, but anyways, point I'm laboring to make is that I've been on a bit of a buying spree, and on the one hand I don't need any more stuff, but on the other hand some of this stuff I just couldn't pass up, and so we've got some more episodes, flea market find episodes coming up. Hopefully those of you who watch those and enjoy them will enjoy these as much as you've enjoyed the other ones, and for those of you who don't enjoy those, well, just bear with me. I'm going to try and I'll pepper in some episodes of some other stuff in between. I know I made a promises a while back about getting to some of these other projects that kind of got stalled, so I'm going to do my best to get cracking as fall is almost upon us. This morning I'm working on the Vernon Lathe. The only thing I've done since the last time I worked on it was I used the shop crane to take some of the weight off of the headstock end so I could shimmy the thing across the floor and get it closer into its final position here in my shop, which is closer to one of the outside walls. I can't get too close because the actual, I don't know if you can see that, but the actual whole bracket assembly and everything kind of sticks out pretty far from the back with the motor on it. But that suits me just fine because I needed some space behind there anyways for the tapering jig assembly to stick out from behind. And then if there is a need for me to, if for some reason I need to get behind the lathe, I actually can. That just takes up more of my floor space, which is kind of precious, especially now with so much stuff here in the shop. Anyways, so I just put the gearbox up top there, and there was a whole series of washers that were used as spacers, big stack of about 10 washers, and they were used as spacers where that rod goes through to control the left to right position of that gearbox. Alright, so those washers are going to control the position of this box this way or that way. And I figure the way I'm going to put those washers in is so that I have the optimum alignment, center line to center line, of this large sheave on the comb pulley and the flat belt, the big wide pulley that goes on here, because I have a lot more leeway on that side with the V-belt pulley, because that motor mount is basically just a metal bracket with some, I think it's even got some slotted holes in it, so I've got some more play on that side, so to speak. So I think this is, since this is a fixed point, I'm going to work off of here, line this up with this fixed point, and then deal with that later. There's been a cornucopia of, that's not what I want to use for a word.